Hello everybody, welcome to another stream. How are we doing? So, this stream is the final stream until we have all of the entity code generator basically together and working. And we can start trying to use it and just test it out and then make sure it's all good before we move on to the next set of tasks. So here's the list. It's called the do not forget list, which is basically a to-do list, but more extreme, I guess. More immediate. But yeah, so we're going to work on when you change a coordinate, you can move you have to move if the coordinate moves your entity to a different region, then you need to move it to the different region pool. Because region is like is like this grid cell here, and it houses these four entities as an example. But if we move this guy over here, it needs to move from one region to another. I expect these moves not to happen too much, but they will happen. And then we need to Codegen archetype entity remove functions. We also need, I guess let's do that one first because we were kind of ended on that last stream. We want to initialize the whole system. We kind of save that till last. I need to finish off the rest of the iterator, which is basically the initialize functions. So pretty close. And then I guess at the end of it, we're going to do a lovely bit of tidy up. I need to ban that damn phrase. Hang on a minute. What's the bot called again that I use? Fossabot, that's it. I've got a way to block some words. Hopefully this will do it. Because it used to be get back to work, didn't it? Let's see if this works. Oh, sorry. Yeah, be careful. I'm gonna put this one to ban. I could just delete the chat message, to be honest. Maybe delete chat message. Someone can test that out. You won't get banned. I promise. It's delete. That'll do it. Hopefully. Oh, sorry. You got time. Oh my days. You got timed up by 300 seconds. Want to be it. Well, you tested your own fate there. But I do like your style. Good evening, Devastated. Welcome. How am I doing today? Yeah, not doing bad. Yesterday was my wife's birthday. We had a good time. Took her to Blue Water shopping center. Bought lots of things because I typically like think of a present, but I couldn't think of one this year. So take her shopping. Clean up API design and Codegen. That's the final thing we want to do. But yeah, we had some bad news in the Rose family household yesterday. Really, my wife found out on her birthday that the baby that we've been expecting is passed away at 7 weeks. So yeah, we're just going through the process of a miscarriage right now, basically. So that's kind of some bad news that we've been dealing with over the past couple of days. So yeah, that kind of sucks. But we're we're doing good other than that though. Everything is good. So yeah, it's especially hard for my wife because she's been ill the past couple of weeks and off work and going through a whole lot of stuff with the hormones and everything. So just to go through all of that and not have any payout from it is quite devastating, and obviously to lose something. But yeah, so there's always more time to have more, obviously. But yeah, we're just going through the process of dealing with that at the moment. But yeah, thank you so much. Appreciate it. But yeah, other than that, we've had a good time yesterday. And I spent some more time with family today. Ate some good food. Oh, we had some like Mediterranean grill food. Oh, it's so good. Got a little bit more leftovers of my wife's food for after the stream. It's going to be amazing. So yeah, it's been me. How about you, Devastated? How are you, sir? How you doing? So let's start on code generating some archetype entity remove functions. So if we move to so basically we programmed up some the sort of defer deletes at the start of the next frame. We're going to defer creates, which is basically updating a bunch of how many entities per region, these counters. And I just realized we could probably put an if statement here for these. New count. Oh, I nearly mistyped that. New count. Could probably put an if statement around it, and that saves writing back out to memory. If new count. Now that means you're reading 2 pieces of memory then. I would just keep it. Yeah, we'll just do the copy. So yeah, we basically just bump allocate the new elements that get created into the regions, and then next frame we actually commit the counter over. So here is when we do the deferred delete of the entities, and I wrote the code down. I was like, and we deleted it from the record pool. But the record pool is only used to take an entity ID and turn it to an entity reference. And it's only used for when you have random accessed entities. And then I completely forgot to remove it from the archetype pool. So this is where we need to code gen some functions, and I'm thinking about doing an array of function pointers based on the archetypes, indexing, and calling the function pointer. Which will probably be all right. So it's that versus a switch statement basically. But this means I can code gen some separate remove functions. And then we also have to make sure that we decrement the counter as well. Got to remember that. So yeah, we'll work on that. I'm just going to code gen these functions. So I guess let's get the prototypes at the ready. No, let's do the code gen first. Just get back to the code generator. And then in the source file, we're going to dump out some statics. So archetype, well, let's go to the actual generated C file. See what sort of headers we got. So this is the stuff that's been code generated. Typed identifiers, entity initialization, untyped getters and setters, typed getters and setters. All right. Getting some property arrays for an archetype. Okay, so I guess I'll do a new section. I could just do the bottom. So let's get down here. Let's do another section header. I'm going to go for every archetype. So these are going to be known as the sounds nice though. Taking my wife out shopping for her birthday. I'm thinking thanks. Been doing web dev all day, so I'm pretty tired in the head of this heaving off. Fair enough. Yeah. Hello again, Fussbot working 100%. Yeah, awesome. And thank you for the sub, by the way, if you just subbed. Appreciate it. Don't know where that went in the previous one. Yeah, fair play, Driver stayed. Yeah, programming all day can get tiring. Definitely so. Often I find if you're doing long days, long hours programming, yeah, taking breaks can often, taking like a break and then coming back, you'll still be able to go a bit longer. Like after work, I have 2 hours where I'm just hanging around with the family, eating food, catching up, and then I'll come back in the evening and we'll do another 4 hours. Yeah, I only do that a few times a week, or 2 times in the weekday. Sunday's more of a relaxed day. Just skip sleeping. Yeah. That you can do that temporarily, but yeah. Yeah, sleeping. Yeah. It's definitely needed. So this section had to be archetype remove functions, or just do like this. So the way I'm looking at it is we go over all the archetypes, and what we need to do is copy. So where's my lovely, here it is. So this is the night, you got this coordinate property. This is region 000, region 001, region 010. And this one has, say, like 4 entities in it. And the idea is if I delete the third or the second one, I need to move the fourth one. Let's just do it again up here. So if I have 4 of them, if I delete this one, I need to move the last one to here. Just copy it over. Yeah. So, yeah, I'm not sure if I really want to batch these because I doubt we're going to get times where we mass remove entities from a single region. We might get that, but it will be rare. And trying to optimize the code to do that would just probably make it slower and more complicated. So, should be easy enough to do the function like that. So, I reckon, right? We would like to create a format where it's a lovely void. We're going to say ent archetype name, entity remove, and we're going to then take in a ref. No, just an index. Then we simply figure out what region you are belonging to. Maybe we could pass in the region index as well, because I think that must be possible, right? Where's the it's entity.c. No, we don't have the region. We can work it out though inside the function. It's not a big deal. If I already had it there, I would have passed it in, but I don't. So we can just work it out. So it is simply, so region flat index is index divided by g ent. I forget the exact thing. Archetype, where's the archetype region entity caps? So it'd be globally available. We index with the archetype. So how many? What's the capacity of the entities per region? So we divide by that. So it'd be entity or ent archetype, capital A for archetype. So a divide. It's got a bit of a division in there though. Then after that, we simply want to index into those counts. Index into those counts, pool counts. I guess we'll get the pool as well. Put that there quickly. So we need to get the archetype pool. So it's int archetype pool. Take a lovely pointer. Well, we could just do a... Oh no, we'll need it. Yeah, we'll need this. Pool. So the typed version of the pool. So that'd be in G int, and then again. Wait, archetype pools index with the archetype. Nice. Take the address. Then after you have this, we can decrement this by 1. Well, this is probably have to be shuffled around, but let's just get that in there so we don't forget. Then what else do we need to do? So we need to mem copy across all the different properties. So if we go over all the properties, which is here, set up the format prop so we can use the context aware thing for the properties, and then we want to now basically copy. So be pool property name. I know, but I have a problem with working 12-hour shifts as a site admin. Oh wow, 4 in a row. Right, I've heard that before in the past. With one of my friends, he used to work 12 hours in 4 days, and then every week he would then shift from day to night. So so he would do night shifts one week, day shifts the next week, and then it's just you having to swap over in those 4 days off. It's quite interesting though. You get 4 days on, 4 days off. Or he did at least. Can't see more than 5 hours, fair play. For me, it's about 6, 7. But yeah. Proper Cooper coffee pot. Watch it, Gov. How's it going? Hey, Soulfoam. How you doing, sir? I see you found that same tweet as I found. Damn, that guy. Yes. He's like, straight out of school, OOP. I can't understand why people don't like OOP so much. I hope he listens to my advice and just tries doing something different. But it didn't seem like he would try. Silly. How common are PLC jobs in the UK, dude? In Kent, where I live, there is basically 0. I'm yet to find any C jobs that exist in the UK. Yeah, I don't know of any, to be honest. Is OOP generally looked down upon? Well, I don't use OOP in any of my code base, and I program just fine. And I feel like it's easier to understand. There's less, when I'm not bothering about hyper optimizing stuff, because optimizing does make code more complex. I find that when I'm not using OOP, the code is more simpler, easier to understand, less chasing code around a code base. I understand more of how things work because the implementation is just open and available. You only encapsulate things at the file level or at the module level, right? Not a class level. Code reuse is simply having structures and some functions that help out with those structures, but inheritance never helps me do that. Yes, I'm a media molecule that's in Guildford, but I work from home. So, yeah, but that's C++, not necessarily pure C, but we program in like a C kind of style. Some would say that sort of orthodox C++, if you remember reading that sort of manifesto, I think it was. But yeah, I don't know, like people do all sorts in the code base. There's very different opinions that go around at work, but you know, we all get along fine and stuff. Have our own little corners. I have some day night changes. Same day night changes as him, but to be honest, it's paid very well. Nice. And my plan is to get some more knowledge and find a job, which is 1 day shift. Fair enough. Yeah, I'm from the UK. I live in Kent. I don't really want to disclose exactly where I live, but southeast. It is subtle. It is subtle gripe I have with C++. I agree. It reduces code reusability by tending to draw more dependencies into classes, which is the opposite of how they are sold. Yes, and oftentimes when you inherit from something, you need to chuck more and more stuff into that base class as more things inherit. It's a very... Inheritance is only good for very simple problems. Like we're using inheritance here actually, if I just show you. And this is the first time I've used it in the entire code base. I've got this pool header, where this is the header of every entity pool. It's got a properties bit set, which probably actually needs to get deleted. The record IDs lookup table, how many entities per region, and then I would go into the code, the code that's been generated by the generator, or I meant to go the header file. Yeah, here you go. Each pool has this header as the first field. This is the first time I've done that. And it's just saved me generating less code basically. I've got this more generalized header thing. But yeah, first time I've ever done in this entire code base. And but yeah. And when you start off something with inheritance, usually you'll chuck more and more stuff in there, and then the solution is better solved without inheritance. I was 1 year in Leicester when I was young, and I understand you don't want to leak my address. Yep, that's correct. Yeah, that's cool, Leicester. Yeah, I've been up to Leicester. Got some in-laws there. So we're looking at like basically generating pool property name, index. So we need to do one of the sort of swap remedies. We take the back element, move it in. So you've got this like so I guess I can say, so the destination index is n index equal pool p source index. So we just got to work out what source index is, and bada bing, bada boom. So we just do yeah. Close the function, and jobs are good. So we need to make that source index. So it takes a couple of lines. We've got to make a base region base int index. So it's region flat index times by number of regions per whatever. Yeah, so really we would benefit from like that divide. I think it's a divide instruction in Intel where you can get the divide and the mod in one go. I think it's something like that. No, it won't be because the mod would be. Well, yeah, because the mod would be 0 to whatever the capacity is, and you take that away from. Yeah, so this is fine. Region base index, and then we take the source index is simply like a. Oh, I forgot a semicolon. Source index is region base index plus the counts before you take it away. No, it's after you take it away. I think this is it, right? So, it's plus. So if the count was 5, we want to get index 4 and bring that here. I guess the thing is, right, is if we're at the back, we're at the back. 2 seconds. It's got my my granddad calling me. BRB. Let me just give him answer him. Alright, welcome back. Hello everyone. That's just my granddad calling me because of situations going on in the Rose household right now. It's just giving me a nice courtesy call. Yeah, so we're just let's catch up with chat. What you guys saying? I'm from the Czech Republic. Oh, fair play. If you know where that is. Hey, don't. I've seen a map before. Yeah, somewhere east of here. Time for some evening coffee. Oh no, getting dangerous. Doesn't matter what job you get in the UK, 40% income tax will put you on a janitor's income anyway. Oh, here we go for the spicy polo. Yeah, I don't know if Keir's going to do that, but it's, you know, it's funny how like the Conservatives, when I don't want to really get into politics here, but it's funny when the Conservatives were like on their year of doing the vote, they were like, oh yeah, that 40% tax, we're going to up it by 10k. You know, just sort of please people a bit. But I wonder if they're going to revert that or not. It'd be interesting to see. Is it 40% over 60k now? Yeah, 50k. Yeah, it's 50k. Yeah, it used to be 40k, then they finally moved it up. It's like inflation, guys. And then like yeah. But I wonder if they're going to change it again. Probably. Yeah. Then you talk about increasing it. Yeah, I'm not sure. Yeah. What we're trying to do, we're trying to get the entity count, work out the new count. So what we want to say is if we're trying to remove the entity at the back, just don't do anything. That's what we're trying to say. Just got to figure this one out. So what we're trying to say is if source index equal ent index, then get right out of here. Return early, because there's no need to copy anything, because it'll just be copying to the same location. One tab, close, new line. Right, let's have a good old think about that one. So why don't we code generate it, take a look at the proper code rather than the string code. You know, everyone loves a bit of string code. It makes it that much more readable, right? So if we run the good old entity code generator, we'll realize, shoot, it doesn't work because we've got a semicolon there and it's not concatenating all the strings together. Cool, it's generated. So we move over to the entity generated.c, reload, go to the bottom, and here's the code we've just generated. One for each type. We've got some semicolons here, you know, classic. Just plop that on there. We'll come back and generate in a sec, but let's just make sure it's all good. Yeah. Well, it's interesting because I think, well, from my limited understanding at least, from what I can tell, is that you know, if you just made everyone pay the 20% tax and they can cheat around it basically, then you wouldn't need to tax people 40%. right, you would get enough tax. Like, and the more you increase the tax and more people that pay 40%, means that you're just gonna destroy more and more of the middle class, right? And people will have less spending money. So I feel like the middle class is what creates new businesses, right? The middle class is what creates new jobs, really. You could say, and more competition. And that's what needs to get fueled. So I think they need to really spend more time on actually making people pay 20% tax rather than escaping it. But yeah. Also, I just feel a bit unfair, like overtaxing people as well. There's that situation we have here in Sweden, but I didn't get into politics here now either. Just an observation. The people who can leave will basically, and those who can't will be left. No economy. Yeah. Yeah, well, all we can do is hope that there will be a solution that arises. But yeah. So region flat index we get by taking the entity index divided by the number of entities that can be possibly be in the region. We get the pool. We decrement the count, so we're already removing a count from there. I guess. Yeah, okay, that's fine. Did we ever increment this on the create? Hang on a minute. Oh no, of course we did. Yeah, no, of course we have. Anyway, back to this. Then we say flat index times by number of entities that could possibly be in a region. That's our base entity index for a given region. We add the number of counts in there after we've mutated it. So that would give us, so say if there's 5 in there initially, we've taken 1 away, adds 4. That's 4 will be the last index of the old array. We take that guy. If we're trying to remove the last one, don't remove it. Then we're simply going to copy to where the element we're trying to remove, right? The last element is the one we're trying to remove. And that's basically it. It's that simple. So I think that's everything we want. We've just got to initialize all those pointers. So I think this is it. So in entity.h, there's this sort of entity system thing. Now I think this could be a function pointer. Ent archetype ent remove function, right? So I think we can just simply have an array of these boys and girls, right? So archetype, what did I call that? Entity.c. Right, archetype and remove functions. Noise and archetype count. Done. So we just got to initialize those when we actually fit in that initialize function. So it shouldn't be too hard. But yeah, unless that's just a global. You know, why is it here? Why isn't it just static? You know, if it was static, yeah, you know, why don't we just Why don't we just do that, right? Why don't we just do this? Hang on a minute. So in the code generator, why don't we just do this? So we're going to code gen. So I think we can just code gen. What happened to that music? Yeah, so do that sort of char star format, and we'll begin to do the super lovely things like this. Right, so we make this like some like static array thing. We just right, and it's just gonna fill in so I think surround that. Nice. So I'm missing a close and a couple of new lines, and that semicolon. Well, comma actually is what I meant. Bit of a tab. So that would instead make this sort of like archetype remove functions, and that'll just be global. We can index, get the function pointer, and boom. So we've got to do the print, so I forgot about that one. Cool. So we go back to the here, rather than be gent entity remove functions, they're no longer there. Should be super nice. .h. Yes, they're not in the global. Excellent. So we rerun the code generator. Cool. We can go back to entity.c or entity gen reload, and boom, here we go, right? You got that function pointer. I forgot to write type def. Anyway, we'll write that in there. And then you just got this lookup table which gets you the function pointer to remove the entity. Right, that will solve that problem. So that is the defer delete stuff now done. The next thing is to let's go back to that to-do list. This is C. Yes, it is, my friend. So we're writing a bit of a code generator right now. So you're seeing a lot of strings. So it's a pass that can just run, and I run this sort of code gen script because I've got a yeah, I've got this sort of data description file where I can describe a bunch of properties and a bunch of archetypes that use the properties, and it just code generates all the entity code that I would need for this sort of entity system. Neat. Yeah, thank you so much. If you have any questions about the project, feel free to ask away. I'm happily answer more. So we've just done this one. Let's get rid of that. So now when the coordinate changes, we need to move the entity to another region. Now this gets me thinking, right? with coordinate, I define it in this sort of property thing, but really, it's kind of like a built-in thing. Like every single entity has a coordinate. I don't think I'm going to have a system where it's like, oh, I've made an entity that's coordinateless. Coordinateless. I don't think that's going to be a thing. So we could build it into that sort of like pool header, because every pool has this, and just be like, well, here's all the coordinate properties. And then like, because we've done that, we can define the functions for coordinate get and coordinate set. And then, but I can equally just get the code generator to still generate that. I just push on the field automatically in the code generator. And then what else? Because what I really want, or I'll just say that it has to exist. But what I need is, say if they set the coordinate, like, because you might, so put it this way, let's go into picture time. So as soon as like this entity here, say, moves to this region, it needs to move pool. So when the property changes, I need to check it and be like, did you just move to a different region? And if so, I need to copy you from one pool to another pool. So I think we need to figure out that sort of how we're going to do it, or how we're going to trigger it. So there's a few places as the getters and setters. I think some entity systems have like an event system or something, like, oh, this property has changed, so I can subscribe to that event and then read them all. But I don't think I don't know if that's something I want to build for this. Hey, Basandro, how you doing, sir? Yeah, I don't know if we want to have that kind of system. So in the let's go into the entity.c, generate one. So we have like chord sets. So one of these. There's a few of them. So here's the night reference, and we set the coordinate. Yeah, we set the coordinate, but what we really want to be able to run is something like, you know, if coordinate is in new region, right? Then we want to like shuffle it around in the pool, and we're shuffling it around for every. Yeah, and we probably need to call a new function, like the one we've just. We need to generate a new function like we did for the remove, where it moves things around from one pool to another or something. So this is another thing I've got to kind of understand, is if I set the coordinate right on the for the entity, maybe that's deferred. Maybe whenever we do a set coordinate, it never happens on that frame. It always happens like, so we might say, you know, move this player here, So if it wants to move to the next coordinate, you say like move to there, but it puts it deferred. So then at the start of the next frame, it will check to see if it can move it there, because you might try and move it there, and then turns out that region is filled up. Like, you know, we have this problem, right, where our regions can only fit so many entities in there because we fix allocate the regions and we say we only support 32 knights per region or 32 chests per region, and if you happen to have too many there, we want a way to sort of like safely deny things but still remember. So maybe the way to do that is we have an array, right? It always starts with an array, doesn't it? Have an array of like requests, like, hey, I want to move to here. And then we go over that array and we basically just accept the requests and move them at the start of the frame. And then obviously that'll be animated over the next set of frames, or maybe it's teleported automatically, but that's controlled outside of the system by another thing. But in terms of the entity pools and the way they work, I think this coordinate property is special in that the setter shouldn't exist. It should always be its own function. Ent move, and then you put in the coordinate, and then it'll be moved deferred. That's what we called. And so maybe in the code generator, we should say it's read only and add a read only thing to it as well. Yeah, we'll say it's read only, and then we'll offer special. See, I don't know what. See, if I say it's read only, then it's not going to add any setters, but. And then, like, what are you gonna? No setters. So maybe I can add this thing where I say no setters, please, because I want to manually write those for it. I think that's a good solution. I don't know if I ever really want it elsewhere, but it means I can put if statements in some places and we can keep things. My concern though is I want coordinate to be it's in every single one of them. So maybe I could say, or maybe I could just mark it. You know what? Let's just build it in. It's just going to be built in. I think that's the solution. Dead tired after Workerino? Oh no. And I didn't even write code there. Oh man. Yeah, that sometimes happens at work, right? When there's, you know, lots of different things happening. And you don't get to write as much code as you'd hoped. Happens sometimes. Yeah, I'm doing okay. Yeah, there's not been some good news in the Rose family. Past few days. It was my wife's birthday yesterday, but we received some bad news. Yeah, we've been trying for another baby, and it didn't really kind of work out. So we're kind of dealing through that process now of trying to move on from the situation and process things. But other than that, we're doing good. I took my wife out clothes shopping yesterday for her birthday. But we obviously had that bad news lingering around. But we've eaten lots of good food, spent money, and kept distracted. So yeah, just kind of getting over that hump in the Rose family household at the moment. But yeah, Thank you for asking, though. How are you? Yeah, I guess you're tired enough. Yeah. Right, so we're going to build in a property. Build in a property. Well, it should be simple, right? Inside the main function, we zero everything. So I think we can just simply push on. So yeah, gen.prop. I should. So do something like this where we do a nice bump allocate, right? Can't get better than that. But my garbage collection. Core string, literal, chord. Chord. How did it do it before? What did past Henry do? Chord, okay. Chord. Right, there's one. This is all zeroed already, so we just have to add the ones we want. Vector type, I guess we'll do the vector type u32 times 3. Or identifier. Sorry, did I just data type my identifier? Sorry, did I just identify my data type? Whoops. Right, easy peasy. And then what else? Is swizzled. Damn straight. Ding. But yeah, we're not really done the swizzling. I'm just saving that for the future when we actually do SimD. But it's there. Doing nothing. But this, so now what we have to do is when we make an archetype, right, straight away, we push on prop 0, which would be the coordinate one. So I might just hash define here, prop coord, ding. And then when we, so this is when we pass the prop thing in that file, let's get past it all. This is when we pass the archetype keyword. Now, we bump allocate this guy, and then we keep reading the properties, right? When we read the properties, we're sort of like, wait, where is it? Where is it? Oh, it's all there in it. Yeah, it's this sort of code. Pretty easy. So we just take this, put it there, and the whole idea is we bump out allocate an archetype property, and we just say archetype prop, and it's only got one field, which is the property pointer. Took the address of basically gen.properties prop coord, and then jobs are good. So that'll just, you know, push on. So I'll pre-allocate that sort of like property there at the beginning. So if I rerun that entity generator, we're still going to see coord show up here and here, but it doesn't actually exist in that layout file. And then so what we want to do, wait, do I want it to go here though? No, actually, let's undo all of that. I got a better idea. We're just going to stick it. Right, here's the plan. New plan. We're just going to stick it in the entity. So in that pull header, we're literally just going to have like, hey, here's all the coordinates. And I guess we'll manually swizzle it later. I'm not sure. you also have the coordinates here. We can add in some general functions to the entities. So entity reference, prop exists, prop. Yeah, so we'll have a sort of dinit deferred. There'll be a move deferred. See, I wonder if we need this sort of ref prefix to it, because it kind of just... I don't think we need that. I think we can do something, just make it a bit shorter. Ent property exists, right? Check if it exists. Ent dinit deferred, ent move deferred. So you'll move it to a new location, and then you'll also be able to read it out as well. So you'll be able to say ent chord get. So unfortunately, it's not really a set. Well, maybe I say set deferred instead. Yeah, maybe that's the way. Okay, so why don't we go and fill these in? This should be quite easy. So we go into the source file of entity.c. It's like an ent ref. Where are these guys? So when you have that sort of I think you just get the you go into the archetype pool and just take the header one out, and we've just got the coordinate array in there, and you should just be able to, you know, do the ent ref. Now I think I'm gonna put this in a local for debuggability reasons, and then we'll just say ent index. Now, you won't... Yeah, so you just have a get for it, I think. Well, that sounds ideal. What's this complaining about? Oh. Conflicting types, you say? I think it's just got the thing a bit wrong. That's alright. Right, now the setter, this is where the magic happens. So what this is going to do is push on, which would be interesting, would be four units, because that's a U32, 3 U32s. That'd be nice. It's a nice size, it's 16 bytes. So we'll push onto some queue. Gent. So this would be move queue. So these are all the entities that are requesting to move. And for now, I'll just do like, yeah, stack push. And I think it might not get, it could get quite big. Because I don't want to do like, I don't ever want to make the queue fair. So if you put it into the queue, ideally all of them should just move. You know what, we might double buffer the move queue, and that will solve the problem of trying to remove things. So if you fail to remove it, you can move over to the next frame's queue. Yeah. And then we can swap the memory. So we push on an element. Oh, so I guess we'll call it the ent move request. It's not really a queue at this point. And we just say request ref and ref request coord. So we just push it on there and get to it later. So in the header file, let's go back to here. In the system, we're gonna have this like type def strut and move request. Then I think we'll tidy this up at some point and make it more internal. So we'll say entref ref coord. So you put the move request in and your entity will eventually move there. I guess my concern is if you put multiple requests in. Like, how do you know if the move request has been satisfied is the question, I guess. Maybe it's something to think about. Like, because you could have a really busy scene where you try and move it into a region, but it doesn't move in there. So, because it doesn't move in there, you're left you kind of want to maybe do something else so it could just wait around. But you can't necessarily check, can I move in there beforehand, because there could be other entities performing their logic of trying to move in there as well. So if we put it in this request queue, it sort of resolves it all. I guess the way you know if it has moved there is quite simple. You can do a get on the coordinate, and if the coordinate is moved to the new location, you know it was successful. Right, so I guess there is that thing you can do. So I think we'll roll with this solution for now, and if there becomes any problems in the future, we can always change it around. Move requests. So I think we'll have a next frame one as well. So you'll go over all the move requests and you go over them over all the move requests. Find the ones which I wonder if can you do it all in one array. Yeah, you can probably do it all in one array. You just process the array and you process the array. If you come across one which gets requested, Yeah, we should do one array. Let's just try that out. So I've got a type def, got a core define me some dynamic array. So ent move request. So I've got that dynamic array type declared now. Right, so let's get around that logic around entity.c. Right. So when we start the new frame, this one does the deletes. This one does the, sorry, this one does the creations. This one does the deletions. So now we're going to do the move requests. So we're going to then get a move request. So I guess this sort of the logic where it sort of accepts and denies it, and then we'll do the actual moving logic. So the request will be obviously from gend move requests index like that. So basically on success, we're going to simply we kind of want to just say, yeah, this one's done. We can deallocate this slot in a sense, right? So I imagine there being like a cursor that we're moving along, maybe. Then if it wasn't a success, you want to take that one and move it to the front, right? So I imagine there's like a not successful cursor. Or like fail cursor or something like that. So if you fail to move it, we're going to copy it there for the next frame. So the basic idea is if it's not a success, then we say if, so we just leave it in the same place. So if index is not equal to fail cursor, then we do the copy. If not, we leave it in the same place. And then we always increment the fail cursor by 1, right? So if the first one fails, it just stays in the same place. So maybe you can call this like failed count. Maybe you call it that instead. And then basically at the end you can resize the stack. So then you're only left with the entities that failed to move. So the next frame, you can try and move them again. And they should be retained in the same order. So it's, you know, a little bit more fair. So, right, where's the copy? So the copy is going to be like, hey, move my request, please. Move my request to failed count. Right. So we're moving it from the current slot to the new slot, and then jobs are good. Right, so move request failed. Move to the front of the stack, so we can preserve them to try again the next frame. So now we're going to actually do that success thing. So what we're going to do is we're going to make another one of these sort of like function pointer tables for each archetype, which does the movement logic, right? It's gonna do the remove function call, and then it's gonna do the add. Wait, we've already got this logic in it. It's the create functions. Yeah, you want to call the remove. Yeah, we'll make it a function for it. So it'd be another one of these sort of lookup tables, success. Instead of remove, it's called move. And we're moving it from this location. You see, if you move it as well, you've got to update the record as well. So we need to get back a reference, actually, to be a new ref, shall we say. So you pass in the old reference. You pass in the old reference, you get back a new reference. If the new ref equals the old ref, it failed. But if it succeeded, so it's most likely to succeed, so we'll do that one first. If it succeeded, we need to get the record slot. And so we need the entity ID, which we'll get that. So well, yeah, we'll just update this reference to the new ref. So the entity ID is in the pool so we get the pool, and we should be able to index those record IDs given the ent using the ent reference index for the new ref. See, I wonder if the function could just give us it, you know? Like this move function is going to be maybe the move function could just do it for us. But this is kind of because if we get back the entity ID, it could have just been done in here. Because it's going to have to, when you do the move, it's going to have to move the record IDs anyway. We'll have the ent ID. So you might as well just get it to update. And it'll have the pool pointer as well. Yeah, okay. So we'll do this in the in that move function then. All right, so let's write these move functions. And yeah, should be quite easy. So basically like this remove one that we did before, we want to actually do a move version now. So let's do that. Do a print. Sorry, do a paste. So this is the move function. It returns a new reference. So enter f and takes in a ref. So the basic idea. Wait, we need to know where it needs to be moved to, isn't it? Kind of missed that one. Request coord request ref. All right. So we would like right, it's better. So we would like a coordinate to come in as well. Oh, what did I do there? nref e. So we need to figure out like the new region flat index, see if we can put it in, see if it's filled up. So it's quite easy. New region flat index is a function. Hey. Yeah, hey Colima, welcome, it's been a while. How you doing? It's not my birthday, it's my wife's birthday. Yesterday. How are you doing? Been some time. There's a function. It's like a flat static one, isn't it? I remember now. Ent region flat index from a coordinate. Right. Oh, right. Coordinate. Yep. So divides it, then gives me the flat index. Perfect. So we do something like this. So that'd be our new region. And then when we've got the new region, we can get the count. I didn't call it a flat index, did I? It's called a region index, like a melon. Hang on a minute. Hang on a minute. Cool. This one needs to be a new region. So what we'd like to say is if this is greater than or equal to, but it should just be equal, the capacities for then we simply shall return the old reference, because the new place we're trying to move it to is completely full. Nice. And now we carry on to do the actual move logic, because it will be successful. New Wildem came out on Monday and I didn't buy it. My addiction is over, guys. Congratulations, Salat. Well done, sir. That's cool. You kicked the addiction. Oops, sorry. Why birthday to the other? Better. Thank you. Yeah, I took her out shopping yesterday. Bought her some clothes and a nice candle. Hey, Sleepy Rhino. Yeah, just traded one addiction for the other, you know. That's how you do it. Although there are such things as a healthy addiction, which you can do. That's the other approach, rather than that that suggestion. Yeah. So now we need to perform the move. So the move is the same kind of logic, right? We want a new. So we want to bump allocate. So we need to get the. Yeah, so the new region base entity index, which is the new region. Wait. I also just realized that you don't want to do this if the entity. So the movement is deferred. You don't want to do. You don't want to do this move if it's not actually moving between regions. That's another thing. Right, so I think we'll just write all this code and then we'll solve that problem. We only want to do the copying if we're actually moving between regions. Right, so you have this new sort of base ent index. We then need to bump allocate ent relative index. So it would be whatever this new region flat index is, then we bump it. Bump. Right. What else have we got to change? Move that pull down here somewhere. So, do we need the old entity index? You already have that, so you don't need this one. Now you can calculate the destination. This would be the new entity index. So we can call this destination. That'll be new region base ent index plus ent relative index, something like that. Yep, increment that guy, get the pull pointer. Now we perform the copy. So you go over and perform the copy to DST from the source. Now the source, we haven't really got the source yet. But the source is just extracting out the existing one. So ent ref index ent ref. Forgot some semicolons. And then, right, then at the end, we need to put in the fact that you need to say return an ent ref, which uses that sort of ent ref archetype of the last one with the entity reference of destination index, like that. So yeah, I think that's basically the logic that we want. So let's code gen that, double check it, and then I would like. All right, of course we forgot some semicolon. Classic. Entity generator. Generated. Reload. Right. So here's the movement side of things. So we must move a night entity, what the coordinate. we calculate the new region flat index from the coordinate. We check the number of entities within that region. If it's greater than or equal to the capacity of a region, we then return the current entity reference and say we failed to move it between regions. Then we have a you see a lot of this, right, is just like kind of shared. So I imagine like could we just make it a function and then it calls the actual sort of copy, right? And at the end of the day, the remove is just a copy with similar sort of logic, right? So maybe we should just have one thing which is called night entity copy, and then it does that copy from source to destination, and then yeah, there only has to be one lookup table. Okay, I think we can do that then. That would be better, wouldn't it? So ideally what we're looking for really is still some kind of like, you know, move entity now. It's kind of an internal function. But we'll be like ent move to this new coordinate. It does all of this, then it will just call into that sort of like archetype entity copy. You put in that archetype, whatever the archetype is, which we can get to a local. You then call and go, hey, move to a destination index and a source index, right? And then it will basically do this, and then we simply then return. Yeah, I think this is sensible. Yeah. So this would go. This could probably be again static in that sort of like entity place, I reckon. So we go into entity.c, go to the top of the file. We could just stick it here with these boys and girls. So it'll be an entity move and remove. And we can get this to work quite easy, I reckon. Where's the pool at? Ent pool header pool equal g ent archetype pools archetype dot header. Then need those copy functions. Right, that's really nice. So we need the remove one. So I could say archetype ent archetype ent move ent remove, which is kind of similar logic. Right, so that would be this logic here. Let's go to the top. Right, so in the remove one, we are simply just gonna just place that in there like that. So rather than being this sort of chest pool thing, we shall simply. So you're trying to remove that entity ref. It's a bit of a different logic thing. So you get the entity index, which is ent ref index. So it just pulls out the lower bits. Get the archetype. Archetype. Oh. Yep. So I don't know. Oh, it's defined down here. Okay. Remove that from the counter source index. So if source, then return, then if not, we do the copy. And the copy would then be ent index. Nice. Cool. I think we're in a good place. So now we've got these like functions here, which can then work this move and remove. Can just use that same sort of generated copy function. So now the code generator will just get more simple. So we can literally just remove this remove one, for instance. All this silly logic we was like prototyping out in here just gets deleted. And then we can simply keep this for loop here, which generates the copy. We've got to be careful. This still has to exist in a wait. Copy. Call it end copy. Sure, we'll copy a... Hang on a minute. Destination index, source index, and void it. And I guess we can just throw that all in there like that. Where's my music? Yes, do a copy, go over all the properties, destination source, yes. No returning of anything. And voila. Oh yeah, then do the lookup table. Copy functions. Neat. Nice. Alright, I think we're in a good place. So we should be able to regen that. Hop back. Let's go to the generated side of things again quickly. Just reload that to see it in action. So we just got this one section now which just does a copy, right, between the different arrays, brings them over. Nice. And then in the entity.c at the top, all those new lovely functions which then call into ent archetype ent copy. Copy functions. Hang on a minute, that's not going to be... They're code gen, aren't they? We might have to forward declare at least, but it ain't a big deal. And the prototype's a bit wrong. Neat. DST. Okay, that does the move. Yeah, there's the copy. Let's go back to the code generator. There's one quick tidy up to do. and that is delete that type def. Doesn't need to exist anymore. Then inside entity .c at the bottom. Yeah. So when we do a new frame, we just got to change. So there's no longer this remove functions thing. Now it's just like a. Hang on a minute. If we're removing, why aren't we deallocating the, okay, n archetype and remove and ref noise. So we just call that, that's that static function which does its thing. Now I did say, so here's the move one. Yeah, we'll take that quick. Put it up here. So I did say that this should be removing from the, this should move it around in the record pool as well. So one thing that this didn't do is it hasn't taken the IDs. So if we go to the pool header, so for random access we have IDs. IDs last between frames. References can change between frames, right, as we're moving them around the pools. So to map a reference to an ID, every entity also can index and get the record IDs out. So when we're moving them around, we also need to update this as well. So something to be aware of is when you do a copy. See, should this just be done in the copy function? Because the copy function is going to be copying. Because if you're copying one entity to another place, no, I guess you put it in the remove and the remove ones. Yeah, the move. So just the move needs to do it. So basically, you need to perform the copy. So we need to say, right, pull record IDs. We index with the destination index, and then we're going to do the same thing again. Where we record IDs, and we're copying it from the source index. Now, we need to, like, we've got it here, right? This is the ent ID. What we need to do is actually update the record pool now. So we need to say ent record pool get g ent dot record pool, and we'll pass in the ent ID, and we need to take that reference and give it the new one. So it hasn't made the new reference yet, so we can then just call it where did we last use ent ref? Okay, so we don't really use it. So we can then just say ent ref equal this new one. Then we put ent ref there. So we update the entity reference in the record pool when we move it around. Yeah, so just, you know, bit kind of messy, I guess. Could be cleaned up, but it will do, I think, for now. But it is, yeah. Maybe it could be cleaned up a little bit, but it's all right. It's not the worst code I've seen. Right, so there's the move. Completed, I think. Right. That's good. So remove and move, those work. Anything else that we're missing? See, when you remove, I feel like... Ah, no, that's cool. That's cool. Ah, this is what we forgot. The move, we only want to do this move if you're moving between regions, right? If your player or entity that you're moving actually crosses that boundary into the new region. We're doing it every single time it says, hey, I want to move, right? So... And also, I guess it's got another problem where if the entities, like if a region is kind of full, you try and move an entity into that full region, it fails, and then an entity moves out of that region. There actually was space for it to do the move, right? But it just got, the problem is it just wasn't in the right order when it went over the array. So technically you could keep running this until the fail count is different. Yeah, until the fail count is different. No, sorry, until the fail count stays the same. When the fail count stays the same, then it means that you don't have to go over the array anymore. So that could be another thing that we do. But just quickly, how do we know? So you got this sort of a new region flat index. We can also get the old region. So that would just be with a bit of division. So region flat index. Where's the entity index? So we call it source. Here it is. Bit of source. Source index archetype. So what we're saying is if these two are the same, if region equal new region, then the entity just hasn't actually moved between regions, so that is a success. But if we return entref, then it's problematic, but I think we need to return a boolean. So success, fail, success. Maybe that's all we need to do. Full success. Yeah, because we was going to update some of the information here, but we moved it inside the function now. So if it's not a success, right, that works. So there's one more thing we need to solve then, and that is like, we need to keep running this until the fail count changes. Sorry, until the fail count has not changed. So we're going to have that sort of like previous fail count. So what you would need, I guess you would do a do while loop, but I'm sure I'm going to write a do while loop and I'll end up changing it. Always happens that way. Do while fail count not equal. I just put spaces in these things. Previous, is that right? So fail count needs to be set to 0 at least. And then Mr. Toggle Sir, how you doing? Thank you so much for the raid, appreciate it. Raid and run again, appreciate you, sir. hope you had a good day. Hope you had a good stream. And yeah, I'll see you soon. Hello, Raiders. We're currently working on an entity code generator. And because we're doing some sort of data orientated entities, because I want to try and have like 73,000 entities for this game. So yeah, we're just wrapping up on the code generators today, hopefully. And then moving on to trying to actually use it and get some entities working using this system. I have a video going up on my YouTube channel this Friday, so if you're interested in knowing more about this entity system in detail, it will be up on that YouTube channel there. But if you have any questions about the game, feel free to ask away, or the project that we're working on. I can give you a quick demo of some of the rendering stuff we've done. So it still builds and runs. Da-ding. Yeah, it's just like a ray traced ellipsoid renderer. We're still got to improve performance and things, and because I really want to redo the BVH stuff. But we've got PBR. This is just a 5x5 set of 8x8 tiles, being ray traced with a bit of PBR with 2 lights. So yeah, we're just trying to get together some of the core game technologies, and the entity system is one of those pieces. I'm going to be building an editor and edit 3D models and get together some test levels and things like that. Thank you so much. So yeah, hey there, the Libra. How are you doing, sir? Thank you. So you make fail count and is that what you do? So you take the previous fail count that happened, set your fail count to that, then you... Oh no, you don't. It's the other way around. It's the other way around. Right, so take your fail count, set the previous to that. Nice. Then you up... Yeah, but... Oh yeah, and then you set fail count to 0. Right. Then you go over all those move requests. Then you up the fail count for the ones that fail. Then you resize the array to the fail count. Then if your fail count has stayed, or if it's different, it means like you actually managed to successfully move something. So it could have freed up some other move request. So you go over the array again and you process that until... Yeah, then so that will then take your fail count of 3 or whatever, store it aside, reset it, go again. Right, that seems sensible. So I think that's the movement request stuff done. That'll be cool. Right. What's next on the agenda? Let's go back to that lovely code generator and see the list. So when coordinate changes, we need to move the entity to another region. Done. Oh. So we've got to do the rest of the iterator API, which is basically initialization. The entity system initialization, which just initializes everything with a bunch of memory based on some input parameters. And then we need to kind of clean up the API a bit, maybe move some stuff to be an internal, and try and get it to compile. As a non-game dev, this makes me feel such skill issue. Yeah, well, yeah, I guess so. Like, you know, programming is very sort of like, a lot of it is like area specific. There are some like core principles that share between a lot of programming. But yeah, especially when it comes to like rendering is a prime example. There's a lot of specific knowledge for that domain. But yeah. You know, it's just fun just learning a bunch of different stuff and And yeah. But it's cool. What sort of area are you in? The Libra dev. Do you do like C# applications or web development or something? You see, with the iterator API, I might remove that shape stuff, to be honest. I'm thinking about it, and like having collision shapes on the iterator might just be a bit overkill. It might just be beneficial just to, you know, say if you have a radius that this player can look at or whatever, right? Don't put that in the entity iterator. Just get it to put a box around it and go over all those regions that the box collides with, right? If you have like some cone which defines your attack, just put a bounding box around it. Like technically you need to do these 3 regions here, but just put a box around it and just do 4 regions, screw it. And as an optimization, we can possibly do something a little bit more complicated, because it just adds more stuff, right? And adds more checks. And we can always add it in later and just see what the performance increase would be. So I think if we just say iterate area min max, I think that would just be good enough. So we can just implement those then. So we just got to find these 2 getters. No, these 2 iterate next functions. Hey, Open Room XYZ, how you doing, sir? I'm doing alright. Not doing bad. A little bit tired now. It's getting kind of late, but yeah, not doing too bad. The love program is fun because there's so much you can do: rendering, physics, AI, sound, text rendering. Yeah, there's a lot of good, especially when it comes to game development. You can just pick a bunch of different things. That's what makes it so much fun. And also, like, you know, architecting systems. You know, understanding the low level things about systems and programming for that. You know, working with operating system APIs aren't the best, but you just write your platform layer around all that stuff, and off you go. Web dev mostly for work, maintaining SaaS, and some sites for clients. Fair play. Mainly tasks with making websites and backends used for those websites. Faster. Fair play. Yeah. Well, you know what I was reminded of today. Speaking of web development, reminded of Edge, or you know, 2G. And I looked up, I was like, how fast is 2G? And it's like, it's 50 KB a second. And I was like, right, so if I'm gonna download, like, if I'm like, it's like, no wonder why when I see Edge, I basically have no internet connection. Because if I try and load any website, that's like 5 megabytes or whatever it is. So on Edge, it's like you're gonna be waiting like what? It's quite a few seconds, right? I can't quite do quick maths. That's not my thing. But 50 KB a second, it's quite slow. As much I use as much Go in the backend as I'm allowed, but primarily TypeScript. Fair play. Yeah. I've never used TypeScript, to be honest. I've just seen it. I've just seen some of the weird stuff people can do in it, though. So now someone using C, that's what I mostly use professionally. Awesome. What do you work on? Oh, motor drives. Oh. Well, can you define what a motor drive is? I'm a bit ignorant of that. Or I don't know exactly what you mean by that. Can I ask if you know how to compile shaders at runtime in Vulkan? Yeah, you just run the compiler, right? And then when your binary changes, you destroy your pipelines, right? Make sure they're not being used. So you stop your graphics system from going, right? You wait for the frame which is running on the GPU to finish, destroy all your pipelines, reinstantiate all your pipelines, and resume everything. It requires a bit of architecting, but it's possible. It's what Vulkan is really, is just a bunch of architecting. Oh, we use C, star, C++ for engine as well. Oh, that's awesome. Because web devs who don't care about their homepage speed is 10 megabytes when it could be 100k. Yeah, exactly. It's putting in that JavaScript library or whatever, and those images. But then you need to generate GLSL first. No, you don't. You just text edit the GLSL and then you compile it, right? I don't understand the question. Motor drives are the device that controls the electric motor. If it's not motor drives, then it's a different type of electronics. Awesome. Well, I'm glad to see you still using C for that sort of stuff, because around here, shamefully, I saw an embedded software developer job and I was like, oh boy. So I applied for it. And they tricked me. I get in there. Well, it's COVID times, right? So I'm on Zoom or whatever. And they're basically going, you know, because we've got a certain degree of... Wait, what do they say exactly? Because we've got a deadline to reach, right? Want to release by this year or whatever. We're going to use Python. And they're using like the Qt framework. And I was like, that's like, you know, at that point I was just seeing the market. I was desperate for a job, but I didn't accept it. So I just basically convinced them that I could be their C person who could optimize it if it was going to be slow. And they were only going to give me like 30k traveling up to London. I was like, that'd have been 10k out of my wage. It was basically like a deal with the devil, you know? It was like real bad. It was like, hey, you can come and work for these people who call yourself embedded software developers, but you just use Python. Painful. But yeah, I did not take that job. I just, you know. Yeah, it's not just like poor job description. The thing is they knew. Like, there's no way. It was just two people as well. Some guys sold his company, got investment for this new thing, and then like, actually no, maybe it wasn't that. Yeah, anyway, it's just some guys got some investment or whatever, and some other guy who's his buddy and, you know, his lead engineer. But there's no way you call that embedded. Yeah, it's just they knew. Yeah. So I'm thinking we've got this null archetype, and in the iterator it kind of wants. So I think we do null plus 1, so we get it on the first one. What else do we need to set up? So it's sort of like min-max. What is min-max? That's a good point. It's not really readable. But I guess it's a min-max coordinate. So I guess I'll then turn that into some region start and region end with a bit of division. Everyone likes a bit of division. So it's like this line here. Oh no, it should be a function. So we hang on a minute. Min chord. This is like a world space coordinate rather than a region coordinate. Right, so that would go in like it's a region start, region end. It's a region end. Nice. And then region coord will be start on region start. And I think that's all the bells and whistles. Yeah, neat. So that just instantiates the iterator there and boom. So this one says regions. So I guess this allows you to iterate over between some particular regions. So I guess we'll keep that one. You know what? I won't bother calling the other function. I'll be right now. So I think that's the iterator stuff done. We already did that last stream. Oh yeah, I want to delete the shape stuff now. We're just always gonna... Wait, what are we always gonna do? We're always gonna... So we don't need the while loop anymore. Well, I guess we'll keep it there just in case. So we do that, then we break. I'll keep it there just in case we want to add it back. Well, actually, let's just remove it. Just adds a bunch of necessary reading just to realize that it's not needed. What? Oh, let's go to begin. Love me a bit of begin. So if there is no region, right, sorry, if there's no entities at this region, go back to the beginning and advance to the next one. Yeah, that'll do it. Right, so let's go back to the entity generation list, and iterator is now done. So let's see if we can quickly go over and implement the entity system initialize. Hey Temporis, how's it going? Good to see you, it's been a while. Yeah, but on a 3D game. I just showed it right. It'll be like fixed camera pointing down. So yeah, it's all in 3D. During COVID, crap like that was really, really bad here. That and fake jobs, they're never actually intended for hire. Yeah, I don't understand how some of those jobs happen. It's just strange. But yeah, I think we've got a big problem in software development right now where people are willing to like make these trade-offs thinking they're gonna actually do the thing they're hoping they will do, and they will probably just make their code base a pain to maintain and have a whole ton of other problems later on, to the point where they'll sell their product and then just go away and then leave it for someone else to solve, which they will never solve, and you're just left with a crap product. Like, for the fact that he's in Python on that embedded system, which probably was just a Raspberry Pi or something, means that all those menus would have been like proper slow. It's like a little device. Or whatever, you know. Yeah, so... Yeah, and then repeat exactly, go around again. You generate SPV with your compiler? Yes, that's interesting to build a compiler that has to be a lot of work. It took 1 year, 3 months in my spare time. So doing this, what I usually do, Tuesday, Thursday, Sunday after work. Well, I don't work Sundays, right, but after my day. I'll come on here and we'll do 4 hours of programming. It took 1 year, 3 months, and I didn't even know if I was building a C compiler initially. I was just building a shading language, which was C-like. And then I realized, you know what? It should have exactly the same semantics as C, but I'll build some extra bits in for buffers and textures and also have some restrictions, because I won't be able to get C fully working without some of the proper bleeding edge stuff. I wanted to use a lot of the new things like bindless, but I didn't want to be exclusively using like the pointer stuff, which is only available in Vulkan but not in DirectX and Metal. So yeah, I just kept it so there were some restrictions at least. So it took 1 year, 3 months, which was quite good considering. And I didn't have to run optimizer because SpearV already has SpearV opt, so it can just do the optimizations. There are definitely some things I over-engineered in that compiler. Like I thought, you know what, I could make it multi-threaded, and it made it worse. So I wish I could undo that commit, but I've not been bothered to go back in there and undo that. But yeah, it's been good. I've been enjoying using it for this project, that's for sure. So the system initialization for the entity system, we basically have to initialize this data structure from this data structure. And each archetype pool is a union around different archetypes which are code generated. So we might make some initialization functions for these guys in the code generator just to solve the problem. But we'll just go over and just do all this now. So let's take this with us because I can't. I don't want to keep jumping back and forth. And let's just fill it all in. So basically, spec. So I want to do that sort of like core copy array. Copies one array from another array. So yeah, destination source, because this is the way. So these are the how many entities per region for each archetype. So we can fix allocate those regions. So for those who don't know, this is a region, right? So some space I have to define. I don't know what it is yet. Sorry, I'm not sure what the size is yet. But effectively, we have structure of arrays. So the night has a coordinate property, and each region has a contiguous set of properties for that entity. But then the next region sits after it, so we pre-allocate up to the capacity for each region. So that's all we're doing. So when we move entities between regions, they move between these region pools. So when we look for entities within a given region, we just have to look at the entities that are contiguous in these region pools. So there's some trade-off between how big a region is that we have to find. Because yeah, like you don't want the region to be too small to the point where entities will be moving between regions a lot. And the smaller it is, the more regions you look over, and the more they can fill up. No, I don't know. Yeah, there's some weird trade-off, and the bigger they are, the less overlap there will be when you try and check with, when you have some sort of AI that you want to run where you want to check within a certain radius. Right, most of the time you'll stay within a region if they're large enough, but you have to check more entities. But you usually want like enough entities to like fill at least a cache line, maybe a couple of cache lines. You know, there's some trade-off, right? And we've just got to play with some numbers and just see what works best, really. But yeah, that's our system. So gn.region dims equals spec region dims. So it's just copying a lot of this stuff in. Region grid dims. So how many regions there are in 3 dimensions. Still got to figure this stuff out. Can probably change a bit. Then we've got to allocate. Have we copied it all yet? Then we've got to allocate the arrays and things. So core stack init. We're going to init the move requests. I think we could probably just use the capacity from the spec. So this is the number of entities. So I probably should call it. Oh wait, let's go back to here. Entities capacity. Bit of a better name. Entities capacity. Then we would want to initialize the entity record pool, which is that custom pool allocator. That'll just be the record pool, which takes in the allocator. I didn't take in the allocator here, did I? Allocator, spec allocator, spec allocator, then the number of entities there. Pretty sweet. Now the final thing we want to do is go over all the archetypes and initialize. So these will probably be better off with some. So we're going over ent archetype count, which is code generated enum. Then we'll simply just, I think we'll instantiate the common header part, and then we'll go ahead and pass in the pointer to the. No, we won't pass it in, but we'll just say initialize. We'll call like a ent archetype pool init, and then pass in. We don't need to pass in anything, actually. But yeah, we'll index with the archetype. Going to be a function pointer, so we'll get that done. That's for sure. But yeah, I think we need like a. We'll get the ent pool header and initialize the common bits and bobs. So address of gent dot archetype pools archetype dot header noise, and now we initialize all the common bells and whistles here. From where did you learn Vulkan? Did you watch some tutorial or keep a book or the most experiment and try things? So I read a ton of stuff. I watched tons of stuff on YouTube. I read tons of blogs, watched tons of things on YouTube. I implemented things like 5 times over, maybe more. If I was to give you advice, you just focus on some aspect of Vulkan. write some code, try and get it running, but you're just going to assume that you're going to throw it all away. So when you're learning Vulkan, don't try and make this sort of like perfect abstraction thing. Make some abstraction for a specific thing and just try and iterate on that for a bit, and then maybe move to something else, make some abstraction over that thing, and just try and understand how, like, what the API of Vulkan and what it does. And like, we're only using compute shaders for this project, and because we're only using compute shaders, there's not really a lot of pipeline state. So things are like very simple. My header file is like 300 lines of code. I've got a little profiler in here. I've got a texture viewer in here as well. I only just have some buffer 0, memset, clear, copy, dispatch, and dispatch indirect. I don't have any draw calls. It's all done with compute shaders. So in 3D, you typically have to ray trace and tile bin stuff or BVH acceleration structures. And in 2D, SDFs are quite good, but you still have to like tile bin typically. But I wouldn't advise doing, maybe doing compute shaders helps you sort of like understand the API a bit, but it's definitely a simpler API. I've even got upload and read back buffers as well, and obviously creating resources. But obviously rendering triangles is the standard way of doing things. I'm just trying to do something a little bit different, which has its limitations and restrictions. Like, I can't go and render a bunch of meshes with this solution. I have to do different things. But a lot of the complication comes from the state of the rasterization pipeline, because it needs like render passes, frame buffers, graphics pipelines, yeah, extra things, and extra sync code. Yeah, it is a very big task. Have you done any previous graphics programming in OpenRoom XYZ? Like, what's your level of graphics programming? Have you done anything? Have you built something 3D before? So Paul, what we're going to initialize? Right, region counts, and then the next frame ones, right? So these need to be, right, so we need to work out, like, given a region, so maybe I'll pass this information in, but we need to work out, like, what's really the capacities. Cap. So the capacity is like the number of regions times by entity caps thing. So regions count. So it's essentially product to give me a product of all of my region grid dims. And then it's region count multiplied by some archetype, number of entities in a given archetype per region. Now that's the capacity. So then we can do our super lovely core allocate array, and it's a U32, I believe. The allocator is spec allocator. Right, so that needs to be passed into. So actually needs to pass in a few things. Spec allocator, and then capacity. So that's pretty sweet. Let's keep going and figure out. There's a next frame one as well. So when we create entities, we bump allocate them into the regions, but we only increment the next frame counter. And yeah, and then at the beginning of the next frame, we commit the counts for those regions right here. So then we accept those created entities at the beginning of the next frame, so we don't accidentally iterate over them in the frame that we create them. Then we need the coordinates array. That's a kind of built-in property. So that's just like that. And then we need record IDs. Oh, I didn't set up the record IDs. And also properties bit set isn't even used. Let's get rid of that. Oh wait, it is used. How are we going to do that? Oh, we can initialize that in the okay, that's fine. Record IDs. Right, so before I forget, those record IDs, when you add an entity, so that's like where is that? Is that in the generator? In it. Right. Right, this is a thing. So allocates a slot deferred. It makes an ID as well. Excellent. So it's pretty sweet. N index. And then we simply just need to say pool record IDs, because I never initialized this. N index equals dref of ID out. Nice. So effectively, because our entity references only really have a lifetime of a frame, because they could be like the entities can move between pools, but it kind of should rarely happen. Only if they move or get nearby ones get deleted and they get moved over them. We need a way to sort of update the record table. So for entities that have random access, it's a little bit slower. You go into the record pool, get the reference out from the record pool, and then access it from there. Yeah, I built a small engine in OpenGL, multiple lighting, camera, model laying, basic things, some instancing, but now it's done in Vulkan. Awesome. Well, it seems like you've done some things, you have an understanding of how a frame should kind of look. So that's cool. You have some high level knowledge. Because Vulkan is like, it's kind of like a high level GPU API rather than a graphics API now. So it went from high level graphics API to high level GPU API. So you're learning this sort of abstract GPU, which doesn't really expose too much of how it works. Can I show you a video series? Do you know how GPUs work? So ARM have done this sort of Mali GPU training series. There's a playlist on YouTube. And it goes over how like GPUs work under the hood, for desktop and mobile basically. And it's really beneficial if you watch up to the specific stuff. I forget where it is. Maybe, I don't know, keep watching until it starts talking about the Mali GPU stuff intensely. Or if you want to watch that, obviously watch it. But it really give you an insight on like how a GPU actually works underneath. So hopefully when you do some of this Vulkan stuff, you're going, oh, this is just implemented this way. You know, if you have access to any, if you program for any fixed hardware like a console or something, you also get access to how those things work. So it really helps open up the picture, open up like an understanding of how things are implemented in some hardware. But obviously, like a mobile phone, the implementations do vary a lot because they might really abuse the concept and do very specific stuff. Whereas on a desktop, it's a lot more lenient, and typically things are just memory. You know, you just literally write into some memory location, and there isn't really so much special source that goes on anymore. Yeah. So the good thing about the Mali one is it talks about desktop and mobile GPUs, which is beneficial regardless. And another thing as well, if you're only doing desktop, in Vulkan 1.3, they added a thing called dynamic rendering. It used to be an extension, but it's in core. So part of core, you can enable this. So you don't need render passes, you don't need frame buffers. You can just use dynamic rendering, and it just means instead of saying VK begin render pass, you say VK begin rendering, and you give it this big old data structure, which you just say, hey, here are all of my render targets, and the depth target, and the stencil attachment. Bear in mind, you should probably not use a stencil attachment if you don't think you're going to use it. Because it just adds abstraction complexity. If you don't need stencil buffers, just don't support them because it adds complexity to your graphics API that you're making. But this dynamic rendering thing just makes things so much more simple, so much more simpler, because you don't need to make a VK render pass every frame, keep it around for a few frames and then get rid of it. Or you don't have to create a frame buffer and maybe use the frame buffer imageless thing. You know, highly recommend this thing. You just don't need render passes anymore, and it makes things far easier. I still recommend pipeline state objects though, even though there's ways to get around that. I recommend still using pipeline state objects. Right, so glad that we remembered that one. So inside, we still need to do the initialization. Obviously, we need to do that though. We need to code gen some things. We're so close. So we code generate entity init functions. Select those moves. We're right. Okay, the copies, weren't they? So we'll say archetype init. Init. Pool init. So with the pool initializers, type def void ent archetype pool init function allocator. The allocator interface, please, and then I want the capacity for the number of elements, please. Ought to be good enough. So that would then be pool init and pool in it. So, right. So what do we need to do? So we need to go over, for every property, we need to go over, we need to get the pool into a lovely local. And also, where's my lovely local here? I don't see no lovely local. Ent archetype pool pointer. Pool equal address of G ent archetype pools ent archetype yep. Then what else are we doing now? I need to copy that. Oh shoot, we need to say the archetype. Yeah. So I'll copy that up to here. Wrong one. Here. I forgot the tab in all honesty. So you get the pool. We're going over every property and then we're going to instantiate the pool. So it's going to be core alloc array with the data type of the property, then the allocator, followed by the capacity. Now where did I... Oh yeah. Cool. So this thing here. Oh. Right, that's looking good. So that's going to codegen ourselves the initialization. We're missing one more thing though, and that is we need a bit set to be filled in for the yeah, we need a bit set for the basically we've got some like with an entity reference you can get a property for there's some functions like entities, is it like has prop exists, is that it? Yeah, so there's this sort of props bit set where you can take that sort of property enum, which is code generated, and you can check if this entity has this property. And there's also another thing as well in the code generated entities. If you have an untyped reference, right, there's a typed reference and there's a getter, but there's also an untyped reference. What the crap's going on there? Yeah, so it gets the array. I didn't realize it uses that function. Yes, there's these functions that are declared, these property arrays. And the way these work is they use the property bit set, and all of the property arrays are ordered. They're sorted and ordered the same way. And some of them, let me just see if I can make this make any sense. So we declare all the properties in this file, then all of the archetypes say what properties they have. And basically, depending on the order they're declared here, in that property, yeah, so this will be turned into an enum as well as other things. But the way they're declared in the code-generated knight, chest, and tree structure is in the order that they appear here. So essentially, they're just missing some fields from the property list, essentially. So this means we can do some logic where if you have an untyped entity reference or just an archetype, you can just fetch. You can just you can check the property bit set, remove the properties that come before you and count the number of bits, and just offset based on that, basically. And that will get you your pointer out from the SOA data structure. Is that right? Wait, maybe that's a little bit wrong. Let me double check that. So you get the low, you get the self is a bad one. Oh yeah. So you're only getting the lower bits before you. That's it. That's correct. Then how much do I offset from that pointer? Nice. So from the generated code, the generated header file, yeah, they always appear in this same sort of order. But notice how the weapon and armor on this one, but the inventory and the bit flag one are only on this one. So yeah, you can get the offset from this and grab any one of these fields with this trick. So we need to fill in this sort of property bit set thing. So we need to have another line which starts the initialization of that. So it'll be called pool props bit set. And we could probably actually just initialize it to 0. And then each one of these is going to all equal the one shift left of whatever the property is, right? So it'd be ent prop p, basically. That'd be alright, isn't it? So I think we should be able to code gen that, and then we'll take a look. So we go to the generate code, reload it, go to the bottom. So we made these initializers now. Gets the pool, initialize property bit set. All's on the fact that it's got health, it's got mesh, it's got weapon and armor. And then we allocate the arrays, and boom, jobs again. And then we got the lookup table here, nice. And yeah, should be good. Just got to make sure that we're actually entity.c. Right, instantiate, put that there. Boom. That's alright, isn't it? Yeah, I'd have to understand a lot more about how the GPU works. I did not drive into that much. So yeah. We have a similar coding style underscore. It's kind of uncommon, but I find it more readable. Oh, yeah, the underscore is definitely more readable. I use the camel, whatever you call this, title case. The types, I kind of got this from when I programmed in my Rust days. Right, I kind of liked that idea. So basically I programmed that sort of Rust style because I did kind of like it. I got a guy at work though who always teases me that this is completely unreadable and it's a bad idea. But yeah, I definitely like using snake case a lot. I use it for mostly everything other than types. Well, it just is more unreadable, right? Think about it. So you've even got the so we'll just do this, right? Archetype, region, entity caps. So this is just more appealing to the eyes than this. But if it was shorter, it would be even more apparent. And when things just get really long, like the snake case just holds up better. But I guess if you only have short camel case names, then it's not so bad. Oh no, yeah, it's the other way around. Yeah. What's happening? What's this project? Program a game in C with no engine. We got ray traced ellipsoids with PBR. We're taking a break from rendering. We're doing sort of game technologies right now. Currently writing an entity system, a DoD entity system, because we're going to be having 73,000 entities in this game, simulated. So I want to make sure I at least have something which I can tweak around and at least think about the problem ahead of time, so I don't have to refactor my whole code base later. But yeah, we're just currently doing the game technology phase where I want to be building the next 8 months. I'm building some custom editors, so level, model, and material editor. Simple versions, first versions. But we're also building some of the game technology side. I've actually got a video. If you're interested in doing some squats or something and watching a video, you can do that. There's the game tech plan. It's about 10 minutes. And it's the whole plan for the next 8 months. And there's an entity video going up as well about the entity system this Friday. Does it like flat textures of spheres, does it? I guess they're just kind of, I don't know. I can see the aliasing really bad. Let's call this a war. War. Alright, so I think we completed it. So let's just have a bit of a... So I still need to get it compiling, right? I still need to... yeah, things are not going to be compiling. We still need to test it and things. But... So clean up API and Codegen. This is what we need to look at next. Just a bit of a cleanup pass, right? Make sure things are not public things and not like to expose. Make sure things just make sense where they are. Right, I'm not here to make a complete mess of things. But what else? We also obviously want to test it out, use it, celebrate the fact we just made a whole system. Get it plugged in. We'll go to the game tech plan. I've moved this forward, so we're going to produce render data from the game logic side where I have some test entities. They make some rendering things. The rendering thread, where we don't even have threads yet. The rendering system, the graphics system, will just take that render data and then render them. Or render those entities, and we can at least see the regions, debug the regions, you know, and just make sure things just work. What else? Yeah, so we're going to be spending the next couple of streams doing that before we move off of the entity task onto threading and the job system, which would also be a lot of fun as well. Hey, Commerce, welcome. Yeah. I used to have anti-aliasing, but I changed my renderer a bit. So let's have a bit of a. I've got a clock on here. Excellent. So let's clock a bit of logic entity. You know what I mean? So we code generated. Well, we didn't really code. We code generated and had non-code generated code, and that added up to 866 lines, 605 being source code, and 261 being header file code. So and I guess it does the comments and blank lines separately. So if we take a look at the code generator, the code generator is 1,000 lines. So what's funny is we've made 1,000 lines of code to make 1,000 lines of code, right? But it's cool because we won't make mistakes when we change things. When we add new archetypes, it's going to increase the amount of code. But it's going to do it all within, I just change this file instantly, or so I rerun the entity generator, and then my thousands of lines has changed. So it's going to be super beneficial for when we change this file, basically in prototype. Yeah, so I'll next be on Thursday, 7:30 p.m. GMT +1, where we'll carry on actually trying to use this entity system now, get it compiling, have a bit of fun there. And then Sunday, 6 p.m. GMT +1. So you're going on the route of a block of memory per archetype. At runtime? Block of memory. Yes, each property allocates a block of memory for each property. So you've got for each property for the whole archetype, you've got your own arrays. Then in those arrays, they're segmented by regions. So so per region you've got, so you might say for the night per region, we're going to have 32 nights per region at most. And so we're never allowed to move more than 32 nights in that same region. We've got ways to restrict that. So what happens then is when you look up, when you have an entity that looks within a region, it has some attack that spans this, it looks over all the entities within that region. And it might want to just look at the health components. So it just scans over all the healths for all the archetypes that have health. And then it will, hopefully only pull in the cache lines that are necessary. But it might span multiple regions, so I do multiple regions, iterate over those. So I hope that answers your question. So we won't be iterating over every single entity in the whole world, just ones that are kind of local. Yeah. But yeah, the video that's coming out Friday on my YouTube channel explains it in full. Maybe raid the Zig guy. Yeah, he's done like a kernel module for regex. Let's have Ogenda. See if there's anyone else. Let's raid the Zig guy. Alright. So yeah, have a good Wednesday, everyone. Hopefully see you all Thursday. Yeah, remember YouTube, go check that out. VOD channel, Discord, if you come and hang out. Much love. Have a good one. Bye-bye. Bye. Red Cabin Games. Fair play. What was Red Cabin Games, Lipo? I have no idea. Just thank you. Appreciate it, sir. Bye-bye.